So we have an example here where we're going to consider the following acceleration. And remember, acceleration was the double derivative of your position. So if you were given your position function, we could take the derivative to find your velocity function. If we took the derivative of the velocity, that gave us acceleration. So we're given what the initial velocity is and the initial position of an object moving on a number line. So we want to find the object's position at time t. So we're given what the acceleration is. We're given that a sub t is equal to 9.8. So recall, I just said that this was the same thing. So we want to try to figure out what the velocity is. So this is v prime of t. So first we want to find velocity. So we're thinking backwards. What would have given us, if we took the derivative, 9.8? Well, our function is in terms of t, and so 9.8 t. If I take that derivative, I would get back my acceleration. So we figured out what our velocity function is. The thing is that I could take the derivative of 9.8 t plus 2 and still get back and take the derivative and get 9.8, because the derivative of a constant is 0. I could add any constant or subtract any constant and still get this as my acceleration. So this is where we want to add some constant c, and we want to figure out what c is. And we can do that because we're given information. We are given the initial velocity. We're given when time is 0. So when t equals 0, the velocity is negative 15. So we know that this v sub t is negative 15 at t equals 0. So we're going to use that fact, and we're going to go in and plug those values in here to figure out what c has to be. And so v of t, when t is 0, we're given is negative 15. This is equal to 9.8. Time is 0. So plug in 0 for t plus c. And so here we get negative 15 is equal to c. So we're given the value of what c is, or now we found the value of what c is. So now we know what the exact velocity function is. So our velocity function v of t is equal to 9.8 t minus 15. So we found the velocity function, but we want to find the position function at time t. And so again, position, that is the derivative of the position gives us a velocity. So we know that s prime of t right here is equal to v of t, the velocity, which equals 9.8 t minus 15. So we have to think backwards again. We have to think to ourselves, what would we have to take the derivative of to get back 9.8 t? So remember, when we're taking the derivative, we subtract 1 from our exponent. And so if I subtracted 1 from my exponent to get 1, then I should have had a t squared, right? So this should have been a t squared, 9.8. The problem is, if I leave it like this and I take the derivative now, I had to bring down my 2. So I need something to cancel out that 2 when I bring it down. And so what could cancel out that 2 when I bring it down is dividing by this 2. So I would just kind of play with it and try to figure out what that derivative, why I have to take the derivative to get this back, and then just test it and see and show. So if I take the derivative of let's just me write it over here. If I take the derivative of this 9.8 t squared all over 2, I bring down my power, all times this 9.8 t, subtract 1 from my power all over 2. Those 2's cancel, and we're left with this 9.8 t, which we wanted to get for that piece. Okay, so we got the first term, what we needed to take the derivative to get this first term for our velocity. So now think about it, what would we take the derivative of to get negative 15? Well, we know we need negative 15 here, but if we take the derivative of t is 1. And so negative 15t, if I take the derivative, it would get me back what I have here. Again, we could add any constant to this and get back that same derivative. So we need to use information that they gave us to figure out what c is. And in the problem, they said that our position at time 0 is equal to 0. So s of 0 equals 0. And so let's plug that in and figure out what c is. So if I plug that in here, I get 0 is equal to 9.8 times 0 squared all over 2 minus 15 times 0 plus c. So basically I get c is equal to 0. And so we figured out what our position function would have to be given the acceleration function and the initial value for velocity, or an initial value for our position. So s of t is equal to 9.8 over 2, which I could technically divide, right? So let's just do that really quick. 2 goes into 9 4 times, bring up my decimal point, and I have a remainder of 1. So 2 goes into 18 9 times. So this is 4.9 t squared minus 15 t plus 0, which I don't have to write. Okay, so I just wanted to go over another example because I know you'll see something similar to this in your homework. So one of the examples, I know you start with a velocity function and have to find the position. So you don't have to do it twice like we had to. It's actually called the antiderivative, what we were just doing, but we'll learn that terminology at the end of this chapter. So this is kind of preparing us to what we're going to be getting into at the end of this chapter and the chapter of integration.